Bismillahirrahmanirrahim and Assalamualaikum. I hope that you all are doing fine. This is day 2 and week 3 of class 9 physics, and today we are going to study about gravitational field and the differences between small g and capital G, where small g is the gravitational acceleration and capital G is the universal constant of gravitation that we have discussed in previous topic. Firstly, let's start with the gravitational field. What is gravitational field? A gravitational field is a force field. This field exists around a mass, which is Earth. Another mass, that is us or any other object, introduced into this field will experience a gravitational force. Or we can also say in other words that a field or a region in which Earth attracts everything towards its center will be called as gravitational field. And the direction of the field or direction of gravitational field is always x towards the center of the Earth. The Earth's gravitational field is represented by these lines of forces, similar to the magnetic field. If we are in this region or in this space, we can feel the gravitational field. But if we move farther away from that field, the gravitational field will be weaker. According to Newton's law of gravitation, the gravitational force between a body of mass m and the Earth is equals to F is equals to GMME divided by R square, where F is the gravitational force, G is the universal constant of gravitation, M is the mass of the body, capital ME is the mass of the Earth, and R is the distance between these two bodies' masses center. Now let's say that we have a ball, and when I throw the ball upward, with the passage of time its velocity goes on decreasing. And there will be a certain point that at a maximum height its velocity becomes 0. Now when the body will come down or towards the Earth, you will see that the velocity of the body will goes on increasing. Why does it happens? This is due to the gravitational pull of Earth acting on a body. Whether the body is in contact with the Earth or not in a contact with the Earth. So such a field in which Earth is attracting everything towards its center is known as that field is known as gravitational field. And the force with which an Earth is attracting everything, that force is known as field force. Now you can see the diagram here. To represent this force field around the Earth, we draw vectors of force pointing towards the Earth's center. The inward direction of arrows represent that the force is always attractive to the Earth. Or we can also say that Earth will always attract the body. The crowding of arrows closer to the Earth indicates that the magnitude of force is larger closer to the Earth, and it decreases or smaller when the body is moving away from the Earth. The magnitude of Earth's gravitational field decreases as the object moves away from the Earth's center. So we can also say that this field directed towards the center of the Earth, and the gravitational field becomes weaker as we go farther and farther away from the Earth. If a body is close to the Earth, then it is in the gravitational field, then the field force will be greater. But if the body is moving away from the field or away from the center of the Earth, then the gravitational field force will be also smaller or weaker. Now the question arises, then where does the gravitational field will be stronger? Obviously that the gravitational field will be stronger towards the center of the Earth. And where it will be weaker? It will be weaker if a body is moving away from the earth. In a gravitational field, the gravitational force per unit mass is equals to the gravitational field strength, or the strength of a gravitational field is found by placing a test mass or any object in a field, and it is represented as a force per unit mass, which is equals to gravitational field strength, and it is equals to G. The unit of force is Newton, unit of mass is kg. So the unit of gravitational field strength will be Newton per kg. Gravitational field strength is basically equals to the value of G. As we know that the value of G is equals to 10 meter per second square, so for the gravitational field strength, its value will also be 10 Newton per kg. Why am I writing Newton per kg? Because gravitational field is equals to F over m, force per unit mass. Gravitational force per unit mass. The unit of force is Newton and unit of mass is kg. When I move the unit of mass to the numerator, it will be Newton per kg. Now, how do we get this formula? As we know, force is equals to gmm over r square. There can be any masses. Now, the weight of the body is due to the gravitational force with which the earth attracts everything or attracts a body. So, force will be equals to mg. This m will be cancelled with this m, and resultant we will get is g is equals to capital G m divided by r square. Gravitational field strength is defined as the force per unit mass experienced by a smallest test mass placed in that field. For board point of view, this question is very important, that how can you differentiate between capital G and small g? As we know that we have discussed in previous lecture that capital G is the universal constant of gravitation. We can say that G is the universal gravitational constant. Its value is 6.673 multiplied by 10 raised to the power minus 11 Newton meter square per kg square. And because it's a constant, it means that its value will be constant throughout the universe. Now what about this small g? We have learned about it in acceleration due to gravity's concept of Galileo, that g is the acceleration due to gravity. Its value is 9.8 meter per second square, or approximately 10 meter per second square. Its values varies from one place to another. As we are moving away from the earth, its value will decrease, and if we are moving close towards the earth, the value of acceleration due to gravity will increase. So firstly, we have talked about gravitational field, that gravitational field is the region in which the earth attracts everything towards its center. Second thing, that if we are moving towards the earth's center, the gravitational field force will be greater, and if we are moving away from the earth's center, the gravitational field force will be weaker. Third thing we have discussed was gravitational field strength. The gravitational field strength is defined as the gravitational force per unit mass. Its unit is Newton per kg. Next thing we have discussed is the differences between the capital G and the small g. They can ask you as a short question. Now your assignment is differentiate between small g and capital G. What is field force, or how can we define field force? How can you say that the gravitational force is a field force? We have discussed about it, that if the body is moving away from the earth, its value or its velocity goes on decreasing, but if it is moving close to the earth, its velocity will goes on increasing. So it is due to the gravitational pull of the earth that is acting on the body, whether the body is in contact with the earth or not. So this from this we can say that gravitational force is a field force. And the last thing is explain what is meant by gravitational field strength. So this was all for today. Hope that you are having a great time. Allah Hafiz.